Okay, we have another set of examples. We have 6 to the x minus 2 is equal to 36 to the x plus 1. Can we write these with the same base? Yes, 36 can be written with a base of 6. So this is what we have. 6 to the x minus 2. Now, 36 is equal to 6 squared. We've rewritten 36 as 6 squared. Make sure we put that in parentheses, 6 squared and then x plus 1. We have the same base. So what we have is x minus 2 is equal to 2x plus 2. We need to get our x's on the same side and our whole numbers on the same side. Here, I'm going to move my x to this side and I'm going to move my whole numbers to here. So that is going to be this positive 2 on the other side. That's going to be negative 2 minus 2. This positive x moved to the right side is 2x minus x. Our final answer, negative 2, I'm in the way, I'm sorry. Negative 2 minus 2 is negative 4. 2x minus x is x. Our answer is negative 4. Now here, we have something slightly different, but we still want to respect the rules. Here we have 4 to the x minus 1 is equal to 1 over 64. Can you write 1/64 with a base of 4? Yes. Okay, we have, that blue is fading on. Now we have 4 to the x minus 1. Everyone remembers this. That's 4 to the negative 3. Remember 4 cubed was 64, but it's 1 over 64, so it has to be reciprocated. Same base. X minus 1 is equal to negative 3. That's a negative. We move it to the other side. X is equal to negative 2. Right? So we look at those. Our goal each time is to use the same base. We will not always be able to find the same base. But whenever possible, we want to use the same base for each side of the equation. So we can see these problems. Now, we're going to switch it up a little bit. Okay, hopefully I can get rid of this ink. Let's switch it up a little bit. We'll finish it up here. Four to the x minus 5 is equal to x plus 1. 4 to the x minus 5 is equal to 8 to the x plus 1. All right. And on this side, we have, let's use 9 to the x plus 2. And let's let that be equal to 27. Now, can we write 8 with a base of 4? No. 4 to the first power is 4. 4 to the second power is 16. But we can still find a common base. All right? Our common base will be 2. So now we have 4 is written as 2 squared, x minus 5. 8 is written as 2 cubed, x plus 1. We essentially turn this into a linear equation, all right? Because the bases are 2. Now, I'm going to multiply this up here. That's 2x minus 10, which is equal to 3x plus 3. I use the distributive property here. Okay, now, I'm going to subtract my 2x from both sides. And I'm going to subtract my 3 from both sides. All right, that cancels. That cancels. I have negative 13, and 3x minus 2x gives us x. I simply got my x's on one side of the equation and my constants on one side. Okay, and the last problem, the same thing. 9 to the first power is 9. 9 to the second power is 81. So you can't use 9 as a base, but you can use 3 as a base. Alright, so here, 9 is rewritten as 3 squared, and 27 is rewritten as 3 cubed, 3 to the third power. So now, we disregard the bases since they're the same, and let's go. We have 2x plus 4 is equal to 3. We use the distributive property. 2 times x is 2x, 2 times 2 is 4. Let's subtract 4 from both sides. And my ink is running low. Let's subtract 4 from both sides. That's 2x is equal to negative 1. And when we divide both sides by 2, x is equal to a negative 1/2. All right. So that's what we have in this case.